Hi everyone, this is Lilian Grace Gamayot, and for this video we're gonna talk about the geometric design of highway facilities, particularly on the special facilities for heavy vehicles on steep grades and the bicycle facilities. So first is the special facilities of heavy vehicles on steep grades. Large trucks have different operating characteristics than those of the passenger cars. And as the grade of the highway section increases, the presence of trucks become more pronounced. Thus, it becomes necessary to consider the provision of special facilities on highway with steep grades where high volumes of heavy vehicle exist. And to combat this problem, we have climbing lanes. Climbing lanes are also known as the Crower lanes, is an extra lane that is used for short distances in certain areas to improve safety, ease congestion, and prevent delays. Their main purpose is to allow slower moving vehicles to be overtaken by faster moving vehicles. A climbing lane are usually used on uphill segments of a highway that have a steep grade 5 to 6% grade. And in the past, the provision of the climbing lane is to improve operation on upgrades has been limited because of its additional construction cost. However, because of the increasing delays and the number of serious crashes occurring on those upgrades, such lanes are now more commonly included on the original construction plans, and additional lanes on existing highways are considered as safety improvement projects. And a highway section with a climbing lane is not considered a 3-lane highway, but rather a 2-lane highway with added lane for vehicle moving slowly uphill, so other vehicles using the normal lane to the right of the center line are not delayed. These faster vehicle pass the slower vehicles moving upgrade, but not in the lane opposing traffic as on the conventional 2-lane highway. So because of it is costly the following criteria can be used to justify a climbing lane on a highway improvement project. An upgrade traffic flow rate exceed 200 vehicles per hour. An upgrade track flow rate exceeds 20 vehicles per hour. A 10 mile per hour or a 15 km per hour or greater speed reduction is expected for a typical heavy truck. A level of service exists on the grade, and a reduction of 2 or more levels of service is experienced when moving from approach segment to the grade. And for the design, the following specification must be met. An adequate traffic signs and pavements marking must be provided to ensure that the drivers are aware of the limitation of the movements, and it must start at the foot of the grade with a taper length not less than 50 meter. And the width is to 3.25 or equal to the normal travel lane width. Shouldering must not be less than 1.25 meters. And lastly, climbing lane must end at least 60 meters beyond the crest of the curve or when the safe passing sight distance is achieved. And usually the desired end taper length is 100 meters. For the emergency escape ramps, these ramps are provided on the downgrade of a highway for use by a truck that has lost control and cannot slow down. Its objective is to provide a lane that diverge away from the main traffic stream while the uncontrolled vehicle speed is gradually reduced and eventually brought to a rest. There are 3 types of emergency escape ramps: the gravity ramps, sand pile, and the arrestor bed. Gravity ramps are paid or densely compacted aggregate surface relying primarily on the gravitational forces to slow and stop the runaway. The rolling resistant forces contribute little to assist in stopping the vehicle. These ramps are usually long and steep and are constrained by topographic controls and cost. While the gravity ramps stop forward motion, the paved surface cannot prevent the vehicle from rolling back down the ramp and the jackknifing without the positive capture mechanism. So therefore, the gravity ramp is not really a desirable types of an escape ramp. Sand piles. Sand piles composed of loose, dry sand dumped at the ramp site and are usually no more than 120 meters or 400 feet in length. The influence of gravity is dependent on the slope of the surface. The increase in rolling resistance is supplied by the loose end. The acceleration characteristic of the sand piles are usually severe and the sand can be affected by the weather. And because of this characteristic, the sand pile is less desirable compared to a raster bed. However, at location where inadequate space exists for another type of ramp to be installed, the sand pile may be appropriate because of its compact dimension. Next is the arrestor bed. Arrestor bed has three varieties: the descending grade arrestor bed, horizontal grade, and the ascending grade. So first is the descending. The descending grade arrestor bed is constructed parallel to the adjacent to the through lanes of the highway. Use loose aggregate in an arrestor bed in the increased rolling resistance thus slow the vehicle down. The gradient resistance acts in the direction of vehicle movement, and these type of ramps can be lengthy. And as a result, the descending grade ramps can be lengthy because the gravitational effect is not acting to help reduce the speed of the vehicle. The ramp should have a clear, obvious return path to the highway so that the drivers who doubt the effectiveness of this kind of ramp will feel that they will be able to return to the highway at a reduced speed. Next is the horizontal grade arrestor bed. It is constructed on an essentially flat gradient, and the horizontal grade ramp relies on the increased rolling resistance from the loose aggregate in the arrestor bed to slow down and stop the out-of-control vehicle since the effect of the gravity is so minimal. Lastly is the ascending grade arrestor bed. This is the most common type of ramp na ginagamit. So, the use of the gradient resistance to its advantage, supplementing the effects of the aggregates in the arrestor bed, and in general, reducing the length of the ramp needed to stop the vehicle. The loose material in the arresting bed increases the rolling resistance as in the other types of ramps, while the gradient resistance acts downgrade, opposing to the vehicle's movement. So, for the next part of the presentation, it is the bicycle facilities. The bicycle, a viable alternative mode of transportation, is popular particularly in the urban and suburban areas as a means of transportation or travel within the community, both for recreational and necessary travel. Thus, the bicycle is an important element to the design of highways, and almost all existing highways and street systems can be used for bicycles, but improvements to these facilities are usually required to assure the safety of the bicycle riders. The bicycle lane is the part of the street or the highway specifically reserved for the exclusive or the preferential use of bicycle riders. Bicycle lanes can be delineated by the striping, signing, or pavement markings. These lanes should always be in the direction of the traffic flow. So, these are the typical na mga dimensions dapat. So, let's proceed to the bicycle path. These are physically separated from the automobile traffic and may be used exclusively by cyclists or possibly with pedestrians. The design criteria for the bicycle path are similar to those for highways, with criteria governed by the bicycle operating characteristic. Important design consideration for safe bicycle path include the path width and the design speed, as well as the horizontal and the vertical alignment. So for the width of the bicycle path, the minimum recommendation is 10 feet for the two-way path and 5 feet for one-way path. The width for two-way path may be 8 feet under the following condition: low bicycle volumes at all times, vertical and horizontal alignments are properly designed to provide frequent safe passing condition, only occasional use of path by pedestrians, and the absence of maintenance vehicles. So when the vehicle paths are located adjacent to the highway, a wave area must be provided between the highway and the bicycle path to facilitate independent use of the bicycle path. In cases where the area is less than 5 feet wide, physical barriers such as dense shrubs or fence should be used to separate the highway from the bike path, and a uniform graded area similar to a shoulder should be provided that it is at least 2 feet wide at both sides of the path. Lastly, for the design speed, a minimum design speed of 20 miles per hour is recommended for paved path. For grades greater than 4%, or if the strong prevailing tails winds are prevalent, the design speed should be increased to 30 miles per hour. For the unpaved bicycle path, the minimum design is 15 miles per hour. So that's all for my presentation. Thank you for watching.